What happens if we crush water? If we take ordinary water and keep compressing it over a period of millions of years, what would we ultimately create? Imagine an infinite amount of water in a device capable of limitless pressure. This is what we get. As the pressure mounts, the water's temperature soars. It quickly hits its boiling point, a chaotic dance of heat and force. But that's just the beginning. Pressure gauge hits 100,000 atmospheres. Strange ice forms. At 100,000 atmospheres, the hydrogen-oxygen bonds shatter. The water doesn't just freeze, it becomes a bizarre high-density, solid ice crystal, unlike anything we know. But the pressure keeps rising. The temperature of these particles becomes extreme. They're squeezed so tightly, the gaps shrink. And soon the atoms themselves begin to ionize, transforming into a partially ionized plasma. Water as we know it ceases to exist. Our journey takes us deeper into the heart of the matter. The plasma becomes even denser, a warm, dense matter. Here, atoms are packed incredibly close. And then it happens. Atomic nuclei begin to collide and fuse, unleashing the power of nuclear fusion. Water, now a sea of nuclei and electrons, generates energy at unimaginable levels. At 1 million atmospheres, we enter the realm of warm, dense matter. Atoms are packed incredibly close. And then it happens. Atomic nuclei begin to collide and fuse, unleashing the power of nuclear fusion. As the pressure cranks up, we cross the threshold into uncharted territory. Helium, the simplest of elements, emerges from the fusion of hydrogen. The dance of nuclei continues, forging elements heavier than helium. At 40 million atmospheres, metallic hydrogen, a form of the element under extreme pressure, appears, a substance of immense energy potential, a dream for future technology. The fusion process accelerates. We move swiftly through the periodic table. Carbon, oxygen, neon, all formed in this extreme environment. At 200 billion atmospheres, danger, helium fusion. At a staggering 200 billion atmospheres, be careful. Hydrogen fuses into helium. The matter expands wildly, needing unimaginable containment, or it could unleash city-destroying energy. Here the periodic table comes alive. Each step of fusion illuminates another element. Iron, the end of the main sequence. For our sun, this is where the story would end. But our pressure is far from the sun's core. The electrons within these iron atoms desperately try to resist the crushing force. At 100 sextillion atmospheres, the electrons they're crushed into the atomic nuclei, combining with protons to form neutrons. What was once water has become a neutron star, matter so dense, a teaspoonful weighs billions of tons. If this neutron star accretes even more mass, it will collapse under its own gravity. The final stage, a terrifying, inescapable black hole is formed. From a simple drop of water to a singularity. The universe's capacity for transformation under extreme conditions is truly astounding.